Space is awesome. It holds satellites that allow us to communicate across the globe, monitor Earth's weather, and track the effects of global warming. We've used it to conduct experiments, search for other life, and explore the furthest reaches of our solar system and beyond. Space is also expensive. The Hubble Space Telescope, launched in 1990, cost NASA almost $3 billion. Its successor, the James Webb Space Telescope, is projected to cost the government almost $10 billion. The International Space Station holds the title of the most expensive man-made object ever, with a price tag of around $160 billion, $100 billion of which came from the U.S. Sputnik, the first satellite, was launched in 1957 by the Soviet Union. For the following 30 years, space was dominated by NASA and the Soviet space program, groups who could afford the billion-dollar price of conducting satellite missions. Although other groups, such as amateur radio, the United Kingdom, and Canada also launched during these years, the number and sophistication of their projects were limited by the costs associated with building and launching a satellite. Universities, even those whose research budgets were in the millions of dollars, were effectively excluded from space exploration by its prohibitive cost. In 1999, Professors Jordi Puig-Suari and Bob Twiggs proposed a solution. Small, modular, low-cost satellites that could be launched individually or stacked together like Legos to form more complex missions. Because of their cubic dimensions, approximately 10 centimeters a side, they were called CubeSatellites, or Cubesats for short. One of the major costs of a satellite mission is getting the satellite into space. The heavier the satellite, the more rocket fuel needed, and the more expensive the launch. Cubesats are relatively cheap to launch because of their small size and low weight. In addition, their small size makes them candidates for ride-sharing, when two or more spacecraft use the same launch vehicle to enter into orbit. Cubesat costs are further reduced by their ability to use off-the-shelf components, electronics that you might find at your local hardware store, such as Arduinos and Raspberry Pi microcontrollers. Ever since they were introduced, the popularity of Cubesats has exploded. The number launched per year has grown exponentially, from 10 in 2000 to nearly 300 in 2017. Cubesats are so affordable that even high schools and elementary schools have been able to launch them. Despite their low cost, Cubesats are capable of doing some amazing things. Planet Labs has used a constellation of them to image the entire Earth in a single day, and, more recently, NASA has used a pair called MARCO, A and B, to relay communications from their Mars lander, InSight. Cubesats are proof that size doesn't matter. Our only limitation is our own imagination.